This is the AS Corporeal Maths exam from 2022, Pearson Edexcel. Let's just do it. So we've got matrices here. AB, you can literally just put into a calculator and get this, because you can't be bothered to do it on your own. Times this by 3, just times all the numbers by 3, you get this. KI, I is just the identity matrix, so KI looks like this. You're aiming to do this minus this plus this, which equals this, I believe. Notice how all these numbers just end up either cancelling or making 24s, which is quite nice. And of course, to make this 0, you need k to be minus 24, and we're done. Explain why this doesn't work. Well, b times a you can do. A is a 3 by 2, and b is a 2 by 3. So when you multiply them as they are this way, your result is a 3 by 3 matrix, as we got. But if you swap those over and do a 2 by 3 times a 3 by 2, the result is a 2 by 2 matrix. You always take the rows of the first and the columns of the second. Now, if that's a 2 by 2 matrix, you can't take away a 3 by 3, which C still is, and so that's not going to work. Good. Show the matrix C can be used to solve this. Well, the coefficients of all this are just the matrix C, so we can write it like this. Then we can use our calculators to find the inverse of this matrix and put it over on the left here. Sorry, on the right here, on the left of this vector, and we get this. Again, calculator works this out. You get this, and you have your answer, I think. So that's question 1 done. Question 2. So r is just the magnitude, so it's 4 root 3 squared plus 4 squared square rooted, which your calculator says is that. And then theta is going to be tan inverse of minus 4 over 4 root 3, which is this, and just verify that that seems right, because this is, if you imagine an Argand diagram, in fact I don't think we have to, we're going to draw them in a second, but Argand diagram, this is going to be to the right and then below, so the argument is negative, which pans out. So that's the answer there. Yeah, so it's down here somewhere, so that's good. This is the answer to that bit. And locus of points defined by this, so you want to think of this as z minus 10i, because then we can say it's originating at minus 10i with an argument of pi over 3, so it's a half line, angle of pi over 3 here. Nice little trick here, so we're trying to work out the minimum distance from w to this, which clearly is going to pass it in a right angle, so this kind of distance here. Nice trick here is that tan of this argument here, pi over 3, is the gradient of this line. So the gradient of this line is pi over 3, root 3. So this is the equation in Cartesian, y equals root 3x minus 10, because of course it's at minus 10 here. This line here going through w, if you want it to be perpendicular to this, which you do, has gradient minus 1 over root 3, and obviously y-intercept 0, so that's just that. Let's look for the intersection of these two things to find this coordinate here. So just basically ignoring negative numbers entirely at this point. You get x as this, put that into there, you get y as this. And now all I have to do is say w is essentially just the Cartesian coordinate 4 root 3 comma 4, and I just need to find the distance from there to this Cartesian coordinate, which the Pythagoras will look a bit like this. It doesn't matter which way around you set these, because when you square it, it just all turns out to be the same. Type that into a calculator and you get this, and we'll have the question done. Question number 3 then was about matrices. I have no idea what this is talking about, but it doesn't matter. Point P has that. We're going to reflect it in the plane y equals 0. Always think of a simpler case here. In 2 dimensions, the line y equals 0 is just the x-axis, right? If you reflect a point like 1, 1 in the x-axis, where does that go? Well, the x bit stays the same, the y bit reverses to a negative. So it's a pretty solid guess that in 3 dimensions, the x and the z bits will stay the same, and the y will turn to a negative, and we'll end up with this, and that turns out to be correct. Determine the exact coordinates of r, so r is the image of this under this of 120. Just put in 120s here, and put in 832 here. You can type that into a calculator entirely, and you just get this, so we're done. And that's going to be the coordinates of r. PR is just going to be, there's a few ways to do it, but it actually doesn't really matter because we're looking for the magnitude of PR. I did this one minus this one to get this, which is this, so I did that minus that. It doesn't actually matter if you do this minus this, because when we look for the magnitude of this, we're just going to square all these anyway, so if they were negatives it wouldn't have mattered. And we'll get this eventually. Show that PR is perpendicular to PQ, so PR is this thing as we just found. PQ is, or how do you get from here to here, where you just take away 6 from the y coordinate. So PQ is just that, or it doesn't even matter if you have a minus or a plus 6 here. I guess I probably should have used minus 6. It honestly doesn't matter, because when you dot product this, you're just going to get 0, which shows they're perpendicular, and you still would even if you used a minus here. So maybe I should have, but it doesn't matter, you still get 0. Hence, determine the exact area of the triangle. So what have we learned here? We've learned that PR and PQ have a right angle between them. We know the length of PR is this. So that's one side of the triangle adjacent to a right angle. And we also know that the length of PQ is just 6, because of course it is. So I think we can just work out this area by just doing this length times this length, which is 6, times a half, because those are the two lengths that are perpendicular to each other in the triangle, and we just get that, and I think that'll be the answer. Question number 4, we need to divide by 3 first to make this have a 1 here, which means our root stuff will work. They tried to trick you by missing out the x squared term, but it should be there, so you can just put plus 0x squared if you want to. Now this here is going to be alpha, beta, gamma, delta. It's going to be 2, and then alpha, beta, gamma plus alpha, beta, delta plus alpha, gamma, delta plus beta, gamma, delta. The mix of all 3 is going to be this one, but it's 3 of them, right? So you're going to change the sign of this to a negative because 3 negatives make a negative, so you swap this sign here. And then the combination of 2's equals 0, so that's all the combination of 2's. And then just the singulars equal minus 5 over 3, because again they're singulars, so just need to make it a negative. So if they come in pairs or even numbers, then these are positives. If they come in odd numbers, these are negatives. So okay, now we've got all this. Can we sort this out? Well, here, if we just square this one here, we get this. So squared both sides. But then, think about putting this next to each other. Alpha times alpha plus beta times beta plus gamma times gamma plus delta times delta. That'll give you what they wanted here. And you'll also get alpha times beta plus beta times alpha, so that's 2 alpha beta, and then alpha times gamma plus gamma times alpha, 2 times that. So you have 2 of all of the doubles, and that will be all that you get. Now all of this is 0, so we can just ignore it, and therefore all of this is 25 over 9. Here we can just put these fractions together, so times this one by beta gamma delta, times this one by alpha gamma delta, and so on, top and bottom, and you get this. Of course, you can put all the numerators together now to get this, and you can also factorize out the 2. This is all 7 over 3. This is 2, which cancels with the 2, so you just get 7 over 3. Here, just expand this out. So 3 times 3 times 3 times 3 is 3 to the 4. The next one will be taking 3 3's and one of the letters. So, it will be 3 cubed times delta with a negative, so that's minus 3 cubed delta, or minus 3 cubed alpha, or minus 3 cubed beta, and eventually you can just factorize that and get this. And likewise, when you take 2 3's, you're going to get 3 squared, maybe gamma delta, or 3 squared beta delta, or whatever, and you end up with 3 squared times all the combination of pairs, with a plus this time, because of course 2 of those multiplied together make a positive. And then finally, you can have 3 with all of the triples, and that'll be a negative because you're taking 3 of them, so that makes a negative. And finally, it's just going to be alpha, beta, gamma, delta at the end. You know all of these things. You know this, you know this, you know this, you know this. You can just put them all in, and you eventually get some answer there, which is going to be correct. Question number 5 then. So these are the results in the formula we can use. You need to know the sum of r is n plus 1 over 2, and you need to know the sum of 1 is just n. So okay, that's, obviously we can write this like this, where we separate everything out. We can replace this result with that. That's n into n plus 1 over 2, and that's just n. We can factorize out an n here straight away, and leave behind all the other things. These are just quadratic, so I'm just going to expand it out, and eventually stuff cancels, and you end up with that, which is good. And then explain why this is true. Yeah, this is quite hard to explain, I guess. You have to be, I think, quite careful when you're writing this down. Essentially, just put in r's for a bit and see what happens. Now, every time you hit a 180, or a multiple of 180, which is going to be right at the very end, you're just going to get a 0. So that's good. And then otherwise, tan of 60 is root 3, tan of 120 is minus root 3, times by 2 is minus 2 root 3. So you end up with a situation where you have root 3 minus 2 root 3 plus 0, because every 180 is 0. And then plus 4 root 3 minus 5 root 3 will be the next one, plus 0. And then you keep going and going and going until you reach whenever the end is here. Now the thing is, when you do that, essentially, if we just write this in terms of, if we just ignore the root 3's, you can have 1 of them minus 2 of them, and then nothing. 4 minus 5 of them, and then nothing. 7 minus 8 of them, and then nothing, and so on. And you just end up, if you group them in, like this, you just end up with minus 1, minus 1, minus 1, minus 1. So you just end up with k lots of minus 1s, or k lots of minus root 3's, because I've just kind of ignored them here. And of course the zeros don't matter, so they're just there. And now, I think that's the explanation. Do your best to write that down. Of course, because I've ignored the zeros here, but because each triple donates 1 negative 1 root 3, that means, because there are 3k there, you only end up with 1k there, because 3 of these original terms come together for 1 minus lot of root 3, so that's where that comes from. Do your best to write that down in words, and you'll get the marks. Now here, we know the result for this, except we know it for r as 1, not r as 5. So we change that using the standard way. We go from 1 to n, and then we take away 1 to 4. That will just give us from 5 to n. We have the result for that. We can use the result for that by just putting n is 4 into there. You end up with this. Now this one here, again, same kind of idea. We need to go from 1 to 3n, and then we need to go from 1 to 5. I was a bit of an idiot here and decided that I couldn't use this formula because 5 wasn't in the 3 times table. So I just wrote out all the terms, the first 5 terms, and then worked out what that was. But then, of course, I realized that the 6th term, because it's a multiple of 180, is nothing, and you could have just pretended this went up to 6 and used the formula. In any case, you get minus 2 root 3, and which you end up adding on, and you get this. Now here, you want this thing, which is this, equal to 15 lots of this thing, which is this, all squared. So that's what I've done there. Then you've just got some algebra to do. I squared out the 3, so I sort of factorized the root 3 out here, squared it to make 3, and then times it there, so that made me that. Now I can just expand everything out and maybe simplify a bit, hopefully. Divide everything by n, I guess. There should be an n. What on earth has happened here? Oh no, I've divided by n straight away. Yeah, sorry, I've divided by n, which gives you a solution of n is 0, except that's not very proper, because if you're starting at 5 here, it would be improper to write 0 there. So we'll just ignore that solution. And then we'll solve this, of course. It becomes this, so we get 2 more solutions, except for the same reason, putting a 5 here means you can't really put a 3 there. So that doesn't work. So 49 is I think, the only one that we can use. Question number 6 is about vectors then. So let's do it. So we'll start with this bit here. It says, so it gives you some information about this. And it says, find the value of lambda when the ball is on the ground. If it's on the ground, then its k value is 0 because it's not in the air upwards, it's on the ground. So this thing here is 0. So we just set that to be 0 and we solve for lambda. Calculators can do that immediately. We'll get the answer there. Lambda is a positive constant, so it's going to be 7 over 5. Direction is this. What's the direction when it hits the ground? We just put this lambda into there and we get 1 mark for knowing how to substitute, and we'll have that. Hence, find the acute angle which the tennis ball hits the ground. Now, this question is is I think the most difficult bit about this question 6. So this vector here is the direction vector of the ball when it hits the ground. We just worked out. Now, if I model the ground as being basically the same vector, just without this minus 2, then basically what this vector is doing is it's following this vector along in the same plane, except this vector here is going downwards, whereas this one is going straight across. But otherwise, they're basically perfectly aligned, right? They're in the same plane, which means I can work out the angle here, and that's the angle that this vector hits the ground with. And of course, to work out this angle, I can just do this dot this equals the 2 magnitudes cos theta, and yeah, I'll dot them together, I'll put it all in the calculator, and I'll end up with this. I'll do cos inverse, and I'll end up with that. And I think I'll have my answer. It's important that these two things are the same as these in order to make this vector here sort of follow this one along in the same plane, and then you end up with the right angle, as opposed to being sort of off in some other direction. So yeah, that is one way of doing it. Next, so yeah, I did all that. The nested tennis ball is in this plane. Well, we've been given an r, so it feels quite natural to just dot that with j. J is just the vector 0, 1, 0. So we'll dot those together. Apparently we get 0, which of course means this times this must be 0, which means lambda is this. And then it says it wants the position, so we'll just put that lambda into our position vector here. I've written it as a vector just because I couldn't be bothered to write in j's and k's anymore. Calculator does the job, gets that, we're done. The maximum height above the court of the net is 0.9. Well, our height at this time is 0.92, so it looks like we just squeeze above it. With reference to the model, decide whether the tennis ball will actually go over the net. Well, the tennis ball is modelled as a particle, which means if it actually had any size, these 2 centimeters probably aren't far enough for the ball to actually comfortably get over. So maybe no, is what I put. Induction, everyone knows, is the best topic possibly ever. We'll let n equal 1 first, and we'll just show that if does this work? Well, this just gives you minus 5, 9, minus 4, 7. So yeah, cool, it works, good. So it works. Then we assume it's true for n equals k. So we assume this thing, just these with k's in them. And then we'll test n equals k plus 1, or consider that. So we'll do this to the k plus 1. Standard trick in matrices here is to just break it down to this to the k times this to the 1. This, by the assumption step, is this. So we can write that. We can then multiply these together, this times minus 5 plus this times minus 4. this times minus 5 plus this times minus 4, that gives you the first two. I'll let you do the other two on your own. Simplify those up, you get this, and then at this point, to be honest, you can just bang this matrix down and put k plus 1s in here and just hope that you've got it right. And it turns out I have, of course. Like, it's not too hard to actually do it properly. But as long as you trust your algebra, you can just bang this down there with the right thing in there and just say, good, it works. And then you write the usual couple of sentences that you always write. Just be careful to write this largely like that, and you should get the marks, and we'll be done with the question. The last question here is about volumes of revolution. So we've got this vase here, which is modeled with this curve from the side. And yeah, okay, cool. So it's very tempting to be confused about these 8s. These 8s have no bearing on this 8 here. These 8s are the height of the vase because it's on its side. So we're saying the y-axis is there, and the 8 is that one, and the minus 8 is that one. So what are the a's then? Well, the a's are just halfway along this vase going in this direction, which is of course 4. So the a is going to be 4, because of course when you rotate this round, you'll get the other 4 centimeters this way, which gives you 8 centimeters in total in both directions. We have 2 suitable curves that are suggested for this, and we want to find some stuff about them. So the widest part of the vase is here, where the derivative of the curve is 0. So if we just differentiate this and set it to 0, and this one as well, we should end up with the x-coordinate for that. So differentiate this, you get this. Of course, sine differentiates to cos, a differentiates to nothing. You can set that to be 0, and then of course you just get this is 0, you do cos inverse, you get 90, or plus minus 90 really, because if you just set for 90, you get this solution here. So minus 90 is actually going to find this one. Minus 90 times 2 divided by 45 is minus 4. So it would be minus 4 down here. And now, it's worth mentioning at this point, if you're doing AS maths, you don't actually know how to differentiate sine. So you can't actually do this. Now, you probably should know how to differentiate sine anyway, just as a recommendation. But even then, it's not hard to find the turning point of this anyway, because you're essentially just asking what the turning point of sine is. And you should know that the turning point of sine is at plus or minus 90. Those are the two closest either side. So you just say, well, when is this 90? Well, it's when x is 4, right? 45 times 4 is 180, divided by 2 is 90, or minus 4. So you can do that without differentiating. But anyway, we take this minus 4, we shove it into the curve, and we find y is 6. So this distance here is 6, times it by 2 to find the diameter, and we'll get 12 and minus 4 there. I've said 4 actually because the distance from the base is asking about distance, isn't it? So the distance from this base is 4 in this direction to get to minus 4 there. So okay. Now for b then, so let's differentiate this. I tried to be really clever and do some product rule, and then realized that I wasn't being clever because this is super easy to expand. But I did product rule anyway, so differentiate. Product rule, by the way, works with 3 things. You just differentiate this one and leave the other 2 alone. You differentiate this one and leave the other 2 alone. And then you differentiate this one and leave the other 2 alone. And okay, we want to set this to be 0. Of course, that just means that this needs to be 0. Which meant I needed to expand something worse than what I would have expanded there, which just made me laugh. You get this, you solve it, you get x is plus or minus this. Again, we want to use the negative one, so we put the negative one into here. Calculator says this, and so 5.97 doubled is very close to 12, but not quite. And then this, remember, is the distance from the base to this. So we're going to do minus 8 plus minus 4.62, I would have thought. Is that what I'm going to do? Something like that, and we get this number here. Okay, and the widest part is diameter 12, just over 3. So just over 3 means that this B model was slightly better, because these are both basically 12. So we'll start using the B curve is slightly better. Also, the true answer to this question is the B curve is better because they're about to ask you to start using it. So that obviously makes the B part better. So okay, we're going to we're going to integrate the B model around the x-axis 360 degrees. That's going to be pi integral of y squared dx, which is this. Now this is not the easiest thing ever to integrate. By the way, a is 4. I should have mentioned that I was using that. We're going to integrate between 8 and minus 8. Of course, we need to square this out. I expanded this out, and then I just did the dumb thing of just expanding all of that out, which eventually got me that. So you need to do an expansion here to get 4 times 4, and then 4 times this, and this times this. And then you also need to multiply this by itself at the end and do a second expansion there, which I hope gives you that. We then, of course, I split all the terms into separate terms and then integrated everything. And I eventually got this, and then, of course, I just typed all of that into a calculator and got this. Student pause 1000 milliliters, 1 litre, 1,000 milliliters into a vase and finds there is 100 milliliters left. Now that's very close to how much there should be. There should be 95 left, so he's only 5 milliliters out. So it seems like quite a good model. I think that might be the entire paper done. It is. Thank you for watching.